Hi, Bianca. We've been taking the idea of those factored forms that we used last week when we solved for 0 and turning them into graphs. So what we said was if we have an equation that looks like this, so we have y equals, so we're introducing the coordinate plane again, y equals x minus 4 times x plus 2. We know that's going to be a parabola because if I FOILed this out, x times x would give me x squared, which means it's going to be a parabola. And it's going to open up because the number in front of that squared term is positive. So what we did last week is we took that factored form, that x minus 4 times x plus 2, and we were solving it when it was equal to 0. And we found that x equals 4 or negative 2 when y equals 0, or when that equation equals 0. Well, if y equals 0, what we've just found is the, I didn't draw these lines very well, but we found the x-intercepts of that parabola. When x equals 4 in this equation, the y will equal 0. And when x equals negative 2 in this equation, the y will equal 0. So we found the x-intercepts. And what we've been working on this week is looking at those x-intercepts and figuring out what they are. In this case, 4, 0 and negative 2, 0. Then we're going to find the y-intercept. I can kind of visualize this parabola. I know it opens up, so it's going to go something like that. The y-intercept comes when x is 0. So it's 0 comma something. I don't know what, but I can plug the 0 in for x in the original equation and find out what y equals. So let's just try that and see. If x is 0, then y equals 0 minus 4. And I could plug anything in for x. I want to know what happens when x is 0. 0 plus 2. 0 minus 4 is negative 4, and 0 plus 2 is 2. So if I multiply those together, I get y equals negative 8. That means my y-intercept is 0, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. Down here somewhere is my y-intercept. So the parabola is going to go down like that, and somewhere it's going to turn and come back up. The other piece we're looking for, though, that important piece in the parabola, is the vertex. And that vertex, because of the idea that a parabola is symmetric, that vertex would fall halfway between those x-intercepts. And I can kind of see where that's going to be if I count over 1, over 1, over 1, over 1, over 1, over 1. I could find the dead center where that y-intercept should be. The other way to do that is to average those x-intercepts. So if I took 4 plus negative 2 and divided by 2, that's 2 divided by 2, that's 1. That should be where my vertex is. When the x is 1 is where my vertex is. It's 1 comma something, I don't know what. But again, I can just plug into the equation. So I would do y equals 1 minus 4 times 1 plus 2. 1 minus 4 is negative 3. 1 plus 2 is positive 3. So my vertex should be at, that negative 3 times 3 is negative 9. So down here at negative 9, there's my vertex, and I have my parabola. So it's taking, again, that idea that we talked about last week, the solving the equations by factoring, setting them, the equation equal to 0, because when it's 0, that's where we'll find our x-intercepts, and then finding the y-intercept and the vertex, and a couple more. I don't know what happened. My screen ended up black here. I don't know why. All right, so let's see. In this case, if I look at the equation, I know, again, it's a parabola because if I distributed, I'd have an x squared. In this case, this negative in front of the parabola means it's going to open down. My x-intercepts, I find the same way, though. I set this equal to 0, x minus 3 equals 0, and x plus 5 equals 0. And I end up with my x-intercepts. Those would be at positive 3, 0, and negative 5, 0. And I'm going to put those on the graph as I go. So 1, 2, 3, and 1, 2, 3, 4, negative 5, 0. And this one, again, is going to open down somehow. So again, we found those x-intercepts by letting y be 0. We find the y-intercept by going back to that original equation and letting x be 0. I need to take that negative into account. So it's negative 0 minus 3 times 0 plus 5. 0 minus 3 is negative 3 times positive 5 but then I take the opposite of that negative of that. So this is going to be at negative 15 times the negative is positive 15. So somewhere way up on the graph will be my y-intercept. It's going to go way up to positive 0, positive 15, and then it's going to turn around and come back down again. And that turning point we know is the vertex. And again, I don't know exactly where it is, but I know it's halfway between those two x-intercepts. Two x-intercepts are 5 and negative 3. So if I add those together, 5 plus negative 3 is positive 2. Sorry, negative 5 and positive 3. Negative 5 plus 3 is negative 2, divided by 2 is 1, negative 1. So my vertex should be at negative 1 comma something, and I get that something by plugging that negative 1 into the original equation. So the y will equal negative 1 minus 3 times negative 1 plus 5. So the opposite of negative 4 times 4, the opposite of negative 16 is positive 16, which makes sense with my graph. There's my y-intercept, it's still going up, and then it's going to turn around and come back. All right, so we're finding those important points, the x-intercepts, the y-intercept, and the vertex. We'll do one more with a fraction. So this one has a negative 1/2 in front of it. And we're going to do the same thing we did, all right? So we're going to find the x-intercepts by letting these two factors equal 0. So x should equal 7, or x should equal 1. So 7, 0, and 1, 0 are my x-intercepts, and I'll put those on the graph. There's 1, 0, 2, 3, 4, 5, 6, 7. This one, because of the negative, is going to open down. And now I'm going to find my y-intercept. And again, I do that by letting x be 0. So that would be negative 1/2, 0 minus 7, times 0 minus 1. Negative 7 times negative 1 is positive 7, times negative 1/2 is positive 3.5. So my y-intercept is when x is 0, y is 3.5. So I'm going to put that, it is negative 3.5. I'm going to put that point on the graph. Again, the negative times another negative gives me a negative. So negative 3.5. And then, that does not look right to me. Hold on. Yeah, I guess that is right. All right. My vertex, again, found halfway between. And again, I can count over the same number on each side and kind of figure out where that middle point is. Looks like it's when x is 4. When x is 4, y is something. I don't know what, but I'll plug that 4 in. So negative 1/2 times 4 minus 7, which is negative 3, times 4 minus 1, which is positive 3. So it's negative 1/2 of negative 3 times positive 3. Negative 1/2 times negative 9 is positive 4.5. So when x is 4, 1, 2, 3, 4.5, there's my vertex. Okay, so it's using that information, that idea that two things multiplied together gives us 0, to get some other information on a graph. Another question you might see. So that's about it. We're going to look at some multiple choice questions, but the idea this week is taking that idea of our factored form or our unfactored form, and how does that apply to now the graph of a parabola. All right, hope you're feeling better soon. We miss you, and take care. We'll talk to you later. Bye-bye.